Hello students, in today's session we will do few problems on current electricity chapter. The problems are not very difficult, but they may require very clear understanding of the topic. So, here is your first problem. It is rather simple one. Let us have a look at the problem. The problem says, in the circuit shown in the figure, terminals E, F and G are maintained at potential of -5, 0 and 5 volt respectively. E is at -5 volt, F is at 0 volt, G is at +5 volt. The ammeters and voltmeters are ideal. This one is voltmeter, this is ammeter A2, this is ammeter A1, all are ideal. The reading in ammeter A2 is 0. It is given that reading in this ammeter is 0. You have to find two things: voltmeter reading of the voltmeter, and reading of ammeter A1. This is the circuit. In this circuit, this point is at -5 volt, this is at 0 volt and this is at +5 volt, and it is given that reading of ammeter A2 is 0. You have to find reading of voltmeter and reading of this ammeter A1. So, this is your question. You can take a snapshot. I am getting out of the screen and try the question yourself. It is a rather simple one and I assume that many of you will be able to get it right. Okay. Here I will do the solution for all of you. The question says that this point is at 0 volt potential. If this point is at 0 volt potential, it simply means, just a minute, okay, this point is at 0 volt potential and the reading of ammeter is 0. So, reading of ammeter is 0 simply means that there is no current here, right? There is no current here. Many of you might have a very conceptual doubt that how can these branches have current when they are not closed. These branches does not appear to be closed branches. So, how can one have current here? Dear students, actually these are closed branches. These are closed branches. If this point is at +5 volt potential, how will it be maintained at +5 volt potential without using a cell? So, there is some cell out here, something like this is there. Let us say this point is grounded. For a minute, let us say this point is grounded, it is at 0 volt. So, the circuit might be like this, actual circuit might be like this. This is at 0 volt and this cell is having a potential difference of 5 volt, EMF of 5 volt. Therefore, this point is at 5 volt. So, when the circuit shown appears like this, don't get distracted that if it is not a closed circuit, how can these branches have current? They are actually closed circuit, right? So, they will have current, no issue about it. Right now, there is no current here, which means this resistance does not have any current, which means there is no potential difference across the resistance, which means if this point is at 0 volt, then this point is also at 0 volt. So, we have understood that this point is at 0 volt. So, if this point is at 0 volt, all these points are at 0 volt only, right. So, this point is at 0 volt. Now, this is +5 volt and this is 0 volt. If I move from this point to this point, this is +5 volt. When I move through this cell, when I jump over this cell, there is a gain of 5 volt. So, this point is at 5 volt, this point is at 10 volt. This point is at 10 volt and this is at 0 volt. So, this is a resistance having a potential difference across its terminals. The potential difference between the terminals of this resistance, I am sorry, it is a resistance, potential difference across the terminals of this resistance is 10 volt, and in a resistance, current is always directed from high potential end to low potential end. So, the current in this resistance is in this direction, and all of you must be knowing that value of this current will be 10 volt, the potential difference divided by resistance 2 ohm, 5 ampere. So, current here is 5 ampere, right. So, in this branch the current is 5 ampere, this is for sure. Now, come to this end, this is maintained at minus 5 volt. So, if I start moving from here, this is minus 5, add 5 volt to it and this becomes 0. So, this point is at 0 volt, 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 which means there is no current in this path. The current in this resistance is 0, because there cannot be current across a resistance which does not have any potential difference across it. So, there is no current here and this is 5 ampere current, there is no current here as well. So, this 5 ampere current must be going like this, must be going like this. So, here the current is 5 ampere. Now, the question says that all these meters, ammeters and voltmeters are ideal. So, if it is an ideal voltmeter, it has got infinite resistance, very large resistance. So, this 5 ampere current will not get diverted through this path, because this path has infinite resistance. So, the entire 5 ampere current will be flowing through this path. So, the 5 ampere current is flowing through this path only. The question is so simple, isn't it? So, the first question, voltmeter reading. Voltmeter reading means potential difference between this point and this point. This is at 0 volt, mind you, this is at 0 volt. This is at 0 volt, but when you move from C to B, there is a gain of 10 volt. So, this particular point is at 10 volt. So, this end of the voltmeter is at 10 volt, whereas this end is at 0 volt. Therefore, potential difference between the terminals of the voltmeter is 10 volt. So, the reading of the voltmeter will be 10 volt only. So, this reading is 10 volt, and now it is very simple to answer what is the reading of this ammeter. Ammeter is seeing a current of 5 ampere through it. So, the current is 5 ampere through the ammeter, its reading will be 5 ampere. So, this was a rather simple question, I guess. Let us move on to next question. In the circuit shown in the figure, current of 600 microampere enters through A. I am sorry, this arrow is actually directed like this. Yes. So, a current of 600 microampere enters into this circuit through point A and leaves through point B. This 600 microampere current leaves through point B. The current is 600 microampere. Okay. Reading of the identical voltmeters, very important. Reading of the identical voltmeters V1 and V2 are 20 volt and 30 volt. Reading of this voltmeter is 20 volt, reading of this voltmeter is 30 volt. Resistance here is R, here also it is R, here also it is R. You have to find the value of resistance R. 600 microampere current enters into the circuit from terminal A, it exits the circuit through terminal B, and reading of this particular voltmeter V1 is 20 volt, reading of this particular voltmeter V2 is 30 volt, and you have to find the value of R. So, again you can take the screenshot if you want and give it a try. I guess that many of you will be able to do it. It is not a difficult, very difficult question, but okay, it could be slightly difficult for many of you. So, give it a try. Here I am solving it for all of you. I have no knowledge about the magnitude of current here. So, let me assume that the unknown current in this branch is I1, rather I will write it as X. Okay. So, let the current in this branch be X. So, all of you understand using Kirchhoff's junction law that current in this particular branch will be 600 microampere minus X, the unit is microampere. X microampere is the current here, that is how I am thinking about it. Okay. So, X is the current here and 600 minus X is the current here, got it. Now, the question says that the reading of this voltmeter is 20 volt. The question does not say that it is an ideal voltmeter, mind you. The question does not say that it is an ideal voltmeter, it only says that both the voltmeters are identical. So, they may be having some resistance, they are having equal resistance, but they are not ideal. Okay. So, the current here is x and here it is 600 minus x and the reading here is 20 volt. You need to understand that the reading of the voltmeter is nothing but potential difference between these 2 points, which is same as potential difference across this resistance. Actually, this resistance, if it is placed here or it is placed here, it makes no difference to the circuit. This resistance could be placed anywhere from this point to this point. It does not alter the circuit, it does not change the circuit. And if the potential difference read by the voltmeter is 20 volt, it means potential difference between these 2 points is 20 volt. It means potential difference across this resistance is also 20 volt. When I move from this point to this point through any path, there is a drop in potential of 20 volt. So, if I take this route, the drop in potential is 20 volt, which actually means that potential difference here is 20 volt, which means R into X is nothing but 20 volt. Similarly, the potential difference here is 30 volt. Reading of the voltmeter is 30 volt. So, potential difference here is 30 volt. What does it mean? This current X will now get branched at this particular junction. Some part of this current may go through this path and the remaining part will go through this path. Again, I do not know how much current will flow here and how much current will flow here. Let me assume that current here is Y. Let me assume that current here is Y. Again, you must take a note that the current in these 2 resistors is Y. So, 2R into Y, RY, RY, 2RY must be equal to 30 volt, because the potential difference between this point and this point is 30 volt. The reading of the voltmeter is 30 volt, means potential difference is 30 volt. So, if I move from this point to this point via this route, I face 2 resistors in the path, right. So, obviously, if this is 30 volt, if I move from this point to this point here, the drop in potential will be 30 volt. So, R into Y plus R into Y, which means 2 RY is 30 volt. So, now I can see that I can rather express Y in terms of X. I need not carry 2 unknowns X and Y. I can just find out Y in terms of X. Just take ratio of these 2 equations, divide equation 2 by 1. If you divide equation 2 by equation 1, this divided by this gives you 2y by x is 3 by 2. 2y by x is 3 by 2, which means y is equal to 3x by 4. So, actually what is happening, 600 microampere current enters through this port, this terminal, x current flows through this path and the current here is 3x by 4. So, naturally current here will be x by 4, again Kirchhoff's junction law. If x is the current here, x by 4 goes here and 3x by 4 goes here. So, the total current that is flowing towards this junction must be equal to total current that is moving out of that junction. Therefore, if x is the current going towards this junction, total current going out of this junction must be x. If this is 3x by 4, this has to be equal to x by 4. Okay. So, this much is clear, I guess. Now, 600 minus x current is flowing here, 600 minus x by 4 current joins it, and the current in this branch will be 600 minus x plus x by 4. 600 minus x plus x by 4 makes it 600 minus 3x by 4. So, the current in this path is 600 minus 3x by 4. 600 minus 3x by 4 and there the current is 3x by 4. If you add these 2 currents, 600 minus 3x by 4 and 3x by 4, the total becomes 600, which is right. So, in a way we have verified that the distribution of current that we have drawn over here is actually correct, because the current coming here and current going there, if you add these 2, you get 600, which is right. Had it not been equal to 600, that means we had made some mistake in the distribution of current, but right now it appears to be perfectly all right. So, now the whole current has been expressed in terms of current in each and every branch has been expressed in terms of a single variable x. That is what we have achieved till now. Next, we have got two unknowns right now. R is not known, x is not known. So, somehow we need to create two equations to get their values. We already have one equation in our hand. This is one equation in our hand. In terms of R and X, we are going to use it. I need to create one another equation so that the question can be solved. अभी भी आप रुकना चाहते हैं, खुद से इक्वेशन लिखना चाहते हैं, लिखिए, रुक जाइए. नहीं लिख पाएंगे? लिख पाएंगे मुझे लगता है. देखिए, the another equation can be created just by the knowledge that both these voltmeters are identical. Till now we have not used this given fact that both the voltmeters are identical, which means both the voltmeters are having same resistance. We have not used this fact anywhere. So, this fact given in the question is unused. Why not use it? If R naught is the resistance of this voltmeter, R naught is the resistance of this voltmeter. So, R naught into this current, R naught into 600 minus X, R naught into this current is nothing but 20 volt. Am I right? I hope so. And similarly, R naught into 600 minus 3x by 4 is equal to 30 volt. Or in rather simple way, I could have said that 20 volt divided by this current is this resistance, 30 volt divided by this current is this resistance, and both the resistances are equal. So, why not equate them? So, that is what I am going to do. I will find value of R naught from here, I will find value of R naught from here and equate both the values. So, from the first equation, the value of R naught is this much, and from the second equation, value of R naught is this much, isn't it? So, just by solving this equation, you can get the value of x. Just by solving this equation, you can get the value of x. Shall I do it? मुझे लगता है आप भी कर सकते हो, पर चलो यार मैं भी थोड़े कैलकुलेशन की प्रैक्टिस कर लूँ, भूल जाऊंगा नहीं तो सब कुछ. So, cross multiplication will give 600 into 2, 1200 minus this into 2, it is 3x by 2, 3 into 600 is 1800 minus 3 into x. This is the equation, right? So, if I bring 3x on this side, this becomes 3x by 2 and this is equal to 600. So, x is equal to 400 microampere. Our current is in microampere unit. So, value of x is 600 microampere. Now, value of x is known to you. You can get the value of R. Remember that value of x is 400 microampere. So, keep that in mind and calculate the value of R. This R will be equal to 20 divided by x. X is 400 into 10 raised to the power minus 6 ampere. 400 microampere is 400 into 10 to the power minus 6 ampere. So, 20 divided by this so many ohms is the value of our resistance. Now, you can do this calculation yourself, isn't it? So, this was our second question. Now, let us move on to another question. Just a minute. Yes, this question. This question says that two resistances R each are connected in series to an ideal cell of EMF V volt. These two resistances are connected in series to a cell of EMF V. Three metal balls are connected to the terminals A, B and C. A metal ball is connected to terminal A, another metal ball is connected to terminal B, another metal ball is connected to terminal C. This is what the question says. The central ball has radius B the central ball has radius b, this ball has radius b, and the other two balls have same radius a. This ball has radius small a, this ball has radius small a. These are metal balls. The balls are far apart from one another. The balls are far apart from one another. This is important. Neglect the capacitance of everything other than the balls. In this circuit, balls have capacitance, nothing else has any capacitance. The switch S, it is closed and the circuit is allowed to attain steady state. We wait for circuit to attain its steady state. Find the charge on the leftmost ball. What will be charge on this ball after the circuit attains steady state? That is the question. I am again getting out of the screen. You can take the snapshot of the question and give it a try on your own. Students, if you understand it clearly, the solution is very small. It is not lengthy at all. What will happen after the switch is closed? What will happen after the switch is closed? Once you close the switch, a current begins to flow like this, obviously. Now, current means flow of charge. Some part of that charge, some of the charge that moves out of this positive terminal of the cell, actually it is always the electrons which move, but we find it convenient to talk in terms of positive charge. So, excuse me for that. I am saying that let us assume that this positive terminal of the cell throws out some positive charge. Will the entire positive charge pass through this route? Will it happen? If it keeps happening that the entire positive charge goes like this, then it simply means that these balls will not acquire any charge. But that is not going to happen. Why? Because potential of this point is not 0. So, if this ball does not have any charge and this point is having some potential, this will violate so many principles of physics, isn't it? So, if this point is having a 10 volt potential, that means you have connected a conducting ball to a point having 10 volt potential. So, the ball will acquire charge so that its potential becomes 10 volt, isn't it? So, initially when the switch is closed, charge begins to move, some part of the charge will flow like this and some part of the charge is definitely going to get deposited on the ball. Similarly, I can think it like this, that the positive terminal gives out positive charge and negative terminal gives out negative charge, just to keep things simple. So, similarly, negative charge moves out of this negative terminal of the cell and some part of that charge will get deposited on this ball. Some part will of course go like this. So, simple thinking tells me that this ball is going to acquire some positive charge and this ball is going to acquire some negative charge, that is for sure. In a steady state means now nothing is changing with time, nothing in the circuit is changing with time. The current is not changing with time, the charge on the balls is not changing with time, everything has come to a constant value. So, steady state means nothing is changing with time. So, the ball has acquired, this ball let us say has acquired Q charge and the charge on this ball is not changing anymore. In that case, after the steady state is attained, obviously this current that is moving out of the cell will pass through the resistors like this. No part of the charge is going to get deposited here, because it is in steady state, charge is no more changing. So, neither the charge is flowing like this nor it is getting out. Now, the charge on the ball has become constant. So, in steady state, obviously the circuit simply looks like this. The circuit simply looks like this. There is a current I flowing like this. It is very simple to understand that because both the resistors are equal, the potential difference here is V by 2 and here also it is V by 2. V by 2 volt drop will be seen here, V by 2 volt drop will be seen here. So, after the switch is put on till the time steady state is attained, these two balls definitely gather some charge. This one gathers positive charge and this one gathers negative charge. Now, again it is commonsensical to think that if this ball is having plus Q charge on it, this ball will have minus Q charge on it, because If I think it like this, that some charge q moves out of the battery from the positive terminal, at the same time minus q charge moves out of the cell from its negative terminal. So, if a positive plus q charge goes here, minus q charge goes here, if out of that q charge some part of it, let us say 20% of it goes onto this ball, then out of this minus q charge, its 20% will go on to this ball, because the situation is identical. You look from this side or this side, there is no difference. There are two types of charges, positive and negative. There is nothing actually negative about negative charge. We could have called those two types of charges as red charge and blue charge. It is quite fine. We need not have called the charges as positive and negative. There is actually no benefit of calling a charge positive and negative. We could have called them as red and blue charge. So, let us assume that negative charge which is getting out of this terminal, I am calling it as blue charge. So, the blue charge which is flowing from here, some part of it is getting here onto this ball, and the red charge that is coming out from this terminal, some part of it is getting on here. Because a cell always throws equal amount of positive and negative charge, that is how we can think about it. Actually, it is only the electrons which move, but it is easy to think that a cell throws out plus q charge from its positive terminal, and in the same time it throws out minus q charge from its negative terminal. I am not saying plus and minus, I am saying red and blue charge. So, cell throws out red charge, cell throws out same amount of blue charge. So, obviously, if x amount of charge goes here, same x amount of blue charge will come here. There is no difference. यहाँ plus x charge आया तो यहाँ minus x charge आएगा. There is no difference actually. चार्ज के कलर में डिफरेंस है, ऐसा सोच लो. पॉजिटिव और निगेटिव को मैं लाल और नीला कह रहा हूँ, तो लाल चार्ज में इसका एक 10% कंपोनेंट इधर गया तो उतना ही निगेटिव चार्ज यहाँ से चला, उसका भी 10% कंपोनेंट यहाँ जाएगा. सो ऑब्वियसली इट इज कॉमन सेंसिकल टू थिंक दैट if this ball is having a charge q in steady state, this will have minus q in steady state. The two balls will have equal and opposite charge, that is for sure. And again, what about this ball? I have not been talking about this ball. Again, we can think in a very simple term that this ball will have no charge actually. This ball will have no charge actually. Will it have any charge? No way. If I think of a current that is going here, suppose just for sake of talking, just for sake of ease of talking, suppose the current here is 10 ampere, 1 minute, 10 ampere current goes here. At a moment, 2 ampere current is diverted here, 8 ampere current flows like this, 8 ampere current flows like this. Now, if you think that 3 ampere will get diverted here and 5 ampere will go here, you are wrong, because this is a V volt cell and these are two equal resistors. So, how can current be different here at any instant? It is not possible. These are two equal resistance. So, if out of this 10 ampere 2 ampere goes here and 8 ampere passes through this resistance, that 8 ampere has to cross this resistance as well. So, there is no question of any current in this path at any point in time. So, this ball will actually not acquire any charge. This ball will not acquire any charge. Isn't it? Isn't it? आप ऐसे भी सोच सकते हो, यहाँ से रेड चार्ज निकला मतलब पॉजिटिव चार्ज, यहाँ से निगेटिव चार्ज मतलब ब्लू चार्ज निकला, पॉजिटिव और निगेटिव चार्ज इक्वल अमाउंट ऐसे चले, न्यूट्रलाइज कर दिया एक दूसरे को, ऐसे सोच लो. सो देयर इज नो चांस दैट दिस बॉल विल एक्वायर एनी चार्ज. सो दिस बॉल हैज नो चार्ज इन स्टेडी स्टेट. दिस बॉल हैज प्लस क्यू चार्ज एंड दिस बॉल हैज minus q charge. I hope I am making myself clear. Now, the balls are far apart, which means charge of this ball does not affect the potential of this ball or that ball. Charge on one ball does not affect the potential of other ball. This is at 0 volt in fact. If there is a metal ball having no charge, its potential is 0. So, we can say that this ball is at 0 volt potential. This point is at 0 volt potential, this whole thing is at one single potential. So, if this is at 0 volt potential, obviously all of you can understand that potential difference here is V by 2, here also it is V by 2, which means this point is at 0 volt, this point has to be at V by 2 volt, isn't it? If I am saying that this is at 0 volt, this is at V by 2 volt, this is at minus V by 2 volt, potential difference here is V by 2, Here also it is V by 2. You should not write it as plus V by 2. No way. Minus V by 2, because current is flowing like this. This point is at higher potential, this point is at lower potential. So everything is very clear now. This point is at V by 2 potential, so this ball is also at V by 2 potential. This ball, an isolated metal ball. Why I am saying isolated? Because actually charge on this ball is not having any influence on this ball, and the circuit is in a steady state. So no more charge is actually getting piled up on the ball. The ball is having a constant charge. So this ball is having a constant charge Q, and its potential will be this much, isn't it? Q by C, capacitance. Yeah, simply 1 by 4 pi epsilon naught Q by A, and this has to be equal to V by 2. So charge on this ball is nothing but 2 pi epsilon naught A V. There is a charge on this ball, and this ball will have equal amount of negative charge on it. I hope all of you have understood this question very clearly. If you have any doubt, watch the video again, and I request you once again to keep sharing these videos with your friends, so that the subscription base increases, and after the subscription base increases, I will certainly give you more benefits. Like I promise that I will connect you all in a Telegram group for discussions and problem sharing, but that will be fruitful only when I have some substantial number of subscribers. So please help me grow my subscriber base. Thank you and wish you all the luck.